We're going to look at parallelograms today and rectangles. Tomorrow we're going to look more in depth in this stuff, especially with numbers. Today we're going to look with letters again. So it's kind of like combining, again, what you already know how to do. So we did parallelograms first semester, right? In a parallelogram, it is a parallelogram if both opposite sides are parallel. And we always write parallelogram as PQRS, usually goes in alphabetical order. So in this parallelogram, PQ and RS are parallel, and QR and PS are parallel. So, like we did yesterday, we're going to look at properties of a parallelogram. And we're going to use distance, midpoint, and slope. So the first thing we have to do, like we did yesterday, we need to assign letters to X, Y, and Z. So in we didn't do a parallelogram yet. But what do we usually always start with? What usually goes over here, where Z is? Yeah, usually we make this A 0. Now the thing is, for X and Y, X we go over a different amount. So I'm going to make that B. And we go up a different amount. I'm going to make that C. So it kind of starts out like a trapezoid. Because a parallelogram is like a slanted rectangle. Gentlemen, wake up. I know. Y is A plus B comma C. Otherwise I'm going to move you up here. You can sit right in front. So those are our labels for our parallelogram. Okay, so let's try, now that we have our labels, to answer some of these with a coordinate proof. Okay, so the first thing we're going to look at is both pairs of opposite sides are congruent. What did we talk about yesterday? If it's congruent, which formula are you going to use? Yeah, I'm going to have to check distance. So I need to find the distance of all four sides. Because I want both pairs of opposite sides are congruent. So I'm going to start with X. I hate that it does that. I'm going to start with WX. So, distance formula for WX. Square root. This is going to be X2, Y2, X1, Y1. B minus 0 squared plus C minus 0 squared. So what do we end up with? Yeah, B with the square root of B squared plus C squared. Now you want opposite sides congruent. So now I gotta check YZ. Is that the opposite side? WX and YZ are opposite sides. So, A plus B minus A squared plus C minus 0 squared. What happens here with the A's? They cancel out. So did you end up with the square root of B squared plus C squared again? So I got one pair of congruent sides. Now I got to do it again with WZ and XY. So WZ A minus 0 squared plus 0 minus 0 squared. Okay, sorry. What happens to my 0 minus 0? Cancels out totally, right? So you end up with the square root of A squared, which is what? Just A. So now we're going to look at xy. Square root A plus B minus B squared plus C minus C squared. What cancels out here? And so we get the square root of A squared again, which turns into A. So we have opposite sides congruent. So there's our coordinate proof. What's the matter?
You switch colors now.
I know. Don't ask me why. Sorry, does that annoy you?
No, Victoria was just.
I got a lot of colors. Okay. B says prove the diagonals bisect each other. So if I'm looking at the diagonals up here, W to Y, oops, that was a bad, X to Z, we want to prove they bisect each other. What does it mean to bisect? Cut in half? How can we prove that? Which formula do you think we're going to use? Midpoint. If they both have the same middle point, wouldn't that, like this side and this side would be the same? This side and this side would be the same? So you don't really use midpoint that often. This is one of those things. So when you see the word bisect, think midpoint. So I'm going to find the midpoint of both diagonals. So first I'm going to start off with X to Z, the midpoint. So add the X's, divide by 2, add the Y's, divide by 2. So A plus B divided by 2, C plus 0 divided by 2. Now it looks weird because you can't really add A and B together, right? So I'm just going to leave this A plus B divided by 2. And this just becomes C divided by 2. So that was X to Z. Now let's check W to Y, the midpoint. 0 plus A plus B divided by 2, comma C, well 0 plus C divided by 2. Do I end up with the same point? Because the zeros cancel. So A plus B divided by 2, C divided by 2. So there's our coordinate proof. Diagonals bisect each other. So it's getting into the theory more of math rather than like actual calculations. Okay, last one on this example. Find the lengths of the diagonals of the parallelogram. What do you notice? So for length, which formula am I going to use? Distance. Right? And we're not using, the only time you're going to use slope is when you want to look for parallel or perpendicular. It's the only time you use slope. Okay. So, diagonals. Let's stick with xz first. So, x2 minus x1. B minus a squared plus c minus 0 squared. Okay, now remember we had this one yesterday, and I told you don't bother squaring the parentheses. If it's a plus or minus, don't do anything. Just leave it like that. Because you got a FOIL, and it gets to craziness. So we're going to leave this b minus a squared plus c squared. I know it seems really weird. Listen, the numbers are coming back tomorrow. And the letters go away. What? Yeah, they do come back. Okay. Now let's check w to y. So a plus b minus 0 squared plus c minus 0 squared. So this turns into a plus b squared plus c squared. Are those the same? No. If you think of numbers, b minus a and a plus b are not the same thing. Right? 2 plus 3, is that the same as 3 minus 2? I know, I'm making sure you know. Right? These are not the same thing. And even if I square them, it's really not the same thing. This turns into 25 and this turns into 1. So because these two things are not the same, the diagonals are not congruent. Okay, people see like, okay, there's a parentheses. The only time they would be the same is if this was a plus. Right, because isn't 2 plus 3 the same as 3 plus 2? It's because of the minus that it makes it not the same. And if you look at a parallelogram, do the diagonals look like they're the same size? No. So they shouldn't be. That was not one of the things we wrote down on our chart first semester. This is why I really wish this unit was after the quadrilateral unit, but it's not. Okay, now we're going to move on to a rectangle. So in my rectangle, I got 0, 0, A 0. What's X? And what's Y? Good, good. Glad you're enthusiastic. So, assign coordinates, we did that. To ensure the quadrilateral has 4 right angles. Write a coordinate proof. Ooh. Yeah. The first thing says prove a rectangle is a parallelogram. In order to prove it's a parallelogram, we got to prove opposite sides are parallel. So which formula should I use to prove opposite sides are parallel? There we go. We're going to do slope. Of all 4 sides. We want to make sure XW and YZ have the same slope, XY and WZ have the same slope. So let's start with the slope of, I don't know, WZ. Y's go on top. 0 minus 0, I'm writing small. 0 minus A. What do we end up with? Did you say 2? 0. 0. And isn't it 0 because it's a... The only reason I'm going through the process, you probably look and say that that's a slope of 0, is because on your quiz, the rectangle might not be nice and neat like this. It may be tricky. Now we're going to check the slope from, let's see, I did WZ. I got to do XY. I got to do the opposite. So B minus B over A minus 0. What do you end up with? What kind of slope? 0, because the B's cancel. So I got one pair of parallel slopes. I'm going to check the other side. And yes. So I'm going to find the slope from W to X. B minus 0 over 0 minus 0. Jack, what'd you say it was? Good job. Because the zeros are on the bottom. No, okay. Whatever. And then I'm going to check the slope from Y to Z. Lost it. B minus 0 over A minus A. What do we end up with? Undefined again. Does the A's cancel? So it's a parallelogram because I got opposite sides parallel because they have the same slope. This would be 0. So 0 is on the bottom. Okay, last one. Let's prove the rectangle has congruent diagonals. So we want to prove from W to Y is the same as from X to Z. So which formula am I going to use? I want to prove they're congruent. I got to use distance. So, W to Y, A minus 0 squared, B minus 0 squared. What does it simplify to?
Me. I'm pretty sure that the board's up there.
I'm just going to focus on the 680U that I printed. A squared plus B squared? Well, these two. These guys do. Nothing. X to Z. A minus 0 squared. 0 minus B squared. What do you get? Same thing? So now these are the same. So you have congruent diagonals. So when it asks for length or congruency, you want to use distance. When it asks for parallel, perpendicular, you want to use slope. When it asks for bisecting, you want to use midpoint. Questions?